This video is over Chapter 46, Parametric Equations and Arc Length. So I'm going to start by talking a little bit about Theorem 265. I'm not going to state it here in all of its detail since you have the notes in front of you, but the outline is this. You have a plane curve given by parametric equations. X is f of t, y is g of t. T is bounded between a and b. And we want the length of the curve then is the integral from a to b of the derivative of f squared plus the derivative of g squared, all of that under the square root. I want you to keep something in mind. That what if you just have a traditional function of one variable, y is equal to f of x? You can parameterize that. You let x be your parameter and then y be f of t. And then the graph of this you can think of as a plane curve that's parameterized by these two equations. If we're to use this idea right here, what happens? You have the derivative of y, f prime of t, right here, and we'll square that, but the derivative of x with respect to t is 1. And so this is the arc length function. This is a formula for arc length that we had back in a previous chapter. But for plane curves and parametric equations, this is the arc length formula. We're going to look at example 266. X is e to the t, y is the constant function 4, and t is going to be bound between 0 and natural log of 3. So we start by calculating the derivatives of our parametric equations. X prime is of course e to the t, y prime is 0. So we use our arc length formula. Integral from 0 to natural log of 3, x prime squared plus y prime squared under the square root. This simplifies rather nicely. Fairly easy antiderivative here. Substitute natural log of 3, we get 3. Substitute 0, we have 1. We subtract, and the arc length is 2. Now, at the end of this, I have to make a disclaimer. I actually made this problem a little bit harder than it needed to be, just to demonstrate this formula. Why is that? Well, let's look at the curve. Y is constantly 4. X is defined in terms of the parameter. When t is 0, x is 1. When t is natural log of 3, x is 3. But y is constantly 4. So all we really did is parameterize the line segment that begins at the point 1,4 and ends at the point 3,4. And the length of this line segment is of course 2.